All right, welcome back. So we are still looking at this question. The promoter of the tour industrial wishes to analyze how the price of tickets affect the size of its audience. She takes two prices at 170 and 200 over 10 shows, each which give rise to the following attendances. Okay, so we have those attendances there as indicated in the question. At price 170, we have those attendances. At price 200, we have those attendances. Now, the interesting question that I want us to focus on is basically to perform a t-test to determine whether the mean attendance is the same under the two prices. Okay? Now, this test is made under the assumption that the two variances are equal. Okay, this test is made under the assumption that the two variances are equal. We are not testing for equal variances. We are testing for the t-test to determine whether the mean attendance is the same under the two prices. Now, this test, I've attached a condition to assume that the two variances are equal under the two prices. All right. Okay, so let's see how we perform this computation t-test. So the first thing that we need to do in any hypothesis testing is to postulate the hypothesis, where we have the null hypothesis and the alternative hypothesis. Where we have the null hypothesis and the alternative hypothesis. The null hypothesis will suggest that mean 1 is equal to mean 2, while the alternative hypothesis will suggest that mean 1 does not equal mean 2. All right? And from here, we're going to have the formula for t-test. This is the formula for t-test, and mostly it's given in your examination. So you don't need to stress much to memorize this formula. But just in case it's not given, you might need to memorize this formula. Okay? So if you can see in this formula, there's something peculiar, which is the pooled standard deviation. Which is the pooled standard deviation. So for us to get the pooled standard deviation, we first need to calculate the pooled variance. So we cannot calculate the t-value before we can calculate the pooled variance. So we begin by calculating the pooled variance, and the pooled variance is calculated by using this formula, where N is sample size 1, and then S1 squared, which is standard deviation 1 squared, which is the variance, is variance 1. And N is sample size 2 minus 1 multiplied by variance 2. Then N1, meaning sample size 1, N1 N1 plus N2 minus 2. Okay? So we have this scenario here. So I need to fuse in the formula. Let's see how we get to fuse in the formula. N1 is 10. Variance 1. So standard deviation 1. We calculated the standard deviation area using the calculator. This is a continuation of the question. So the standard deviation is 6.3246. I'll bring it here. 6.3246. 6.3246. Sample size number 2 is also 10. There are two elements under price 200. So 10 minus 1, and then standard deviation 2. So we are going to square the standard deviation 2 to make it variance. So standard deviation 2 is 5.4528. 5.4528. 5.4528. Okay. 10 plus 10, sample size 1 plus sample size 2 minus 2. This is just a formula. And I plead that you master it. Okay, so from here now I can process the computation. I'll get my calculator. Say open brackets, 10 minus 1, that's 9. 9 multiplied by 6.3246 squared, close brackets, plus open brackets, 9, which is 10 minus 1. 9 multiplied by 5.4528 squared, close brackets. I have that number, which is 627.6023. This divided by 10 plus 10 gives me 20. 20 minus 2, it will give me 18. So I'll set 4.87. Set 4.87. Set 4.87. Now with this, I can proceed to calculate my T. Look at the formula for T. That's the formula for T. Okay. So I need mean 1. Mean 1 was basically 117. That's calculated from the data set. So I'm putting 117 here. Sorry, it's not here. It's here. 117 here. Mean 2 calculated as the data is 100.8. There you go. Mean 2, 100.8. Then this which I have is the put variance. What was it? 34.87. Sorry about this. 54.87. This which I have is the put variance. But when we look at this one, this is the put standard deviation, the SP. So I need to square root my put variance to find the put standard deviation. So I'll say put standard deviation. We say SP is equal to the square root of the put variance. It's quite a complex computation, but you just need to master it. It's 4.87. It's 4.87. There we go. Square root of 34.87 is 5.90. Okay, so now 5.90 will come and sit there. N over 1 over N1. 10 there. 10 there. Then now I can calculate my T. Now I can calculate my T. 117 minus 100.8 is giving me 16.2 over. So now I'll say 1 divided by 10, open brackets, 1 divided by 10, close brackets, plus 1 divided by 10, the bottom part. I have 0.2, and then I'll square root the 0.2. I have 0.444, then multiply by 5.9, I have 2.64. 2.64. So now I can get my T, 16.2 divided by 2.64. I have 6.14. That's my T. Then I need to create a decision rule. I need to create the decision rule. Decision rule is to reject the null hypothesis if T at what? T at 18. Let me enlarge this their way. Yes, it could be. Let me see if I can take it to 20. Oh, 24 even better. Okay. If T is greater than T18 at 0.025, which is equal to, I'll look for that one. Now, when we say T18, where is the 18 coming from? The 18 is the degree of freedom. The degree of freedom here is N1 plus N2 minus 2, which is 10 plus 10 minus 2 to give us 18. And we are testing at 5%. This is a two-tailed equal test because we are testing for the difference. So if we are testing at 5%, the 5% will be torn into 2, which will become 2.5%. So the T is coming from the degree of freedom, which is the same as the denominator for the split variance. Degree of freedom N1 plus N2 minus 2. Minus 2 because you added the 2 sample size. Okay? So we need to look for the T in the T tables where it's corresponding to 18 and 0.025. Let me get the T tables quickly. I'm just getting the T tables quickly. Okay, I found a T table. Okay, so if you can see, this is the T table. From this T table, you will see where there is 0.025 and 5%, which is that part. Okay, let me show. Which is this part here. And we'll go to where there is 18. 18 is here. This is the T table. It has to read T table there. Where these two are meeting, that will be our T. And in this case, it looks like it's 1.734. Just here. Oh, sorry. Sorry. 0.025% is here. Not this one. Let me clear this one. Beg your pardon there. So where the two are meeting, it's here. This side, it's 18, the degree of freedom. And the top part, right down. Yeah, this side, it's 18. The top part, is 0.025, and this side is 18, and they are meeting here, 2.101. So that's my T reading. Okay, so my T is 2.101 as read from the table. So now, let's make a comparison so that we make a conclusion. Our calculated T is 6.14. Is it greater than 2.101? Yes, this T that we calculated is greater than 2.101. Therefore, we will reject the null hypothesis because the rule says reject if the T is greater. So the T we've calculated is this one. And it's greater than the T that we found from the table at that address. So we reject the null hypothesis. Okay? We reject the null hypothesis. So we say we reject the null hypothesis. Since T, which T? T calculated is greater than T obtained at the address, which is 2.101. And we conclude that, so what we are rejecting is the null hypothesis which says mean 1 is equal to mean 2. So if we reject this one, automatically the one which will be accepted is the alternative which says mean 1 does not equal to mean 2. So say and conclude that, and we conclude that the mean attendances under the two prices are not equal. are not equal. That's how we do a t-test for such kind of a question, assuming equivariances. Why are we assuming equivariances? We had already conducted a test for equivariances, and we found that the variances are equal under the two prices. And then the question continued to ask us to calculate, to perform a t-test to see if the means under the two prices are the same or different. Okay? So this is where the t-test comes to an end. Thank you very much.